Welcome back to Miss B Makes It Easier, and now we're moving right along with trends in group 2. Now, as you can see here, I have the periodic table. I got a new one. I went on Google, downloaded it. Whoever put it up on Google, props to you. I know everybody could get touchy sometimes, but if it's on Google, it's free range, just like all this video. I'm pretty sure people are going to take it and use it for their own upliftment. So it's all about sharing is caring, and in this way I'm going to tell you thank you for posting this and all the pictures in my video on Google. I appreciate it. So moving right along, the group 2, like what I would have told you in an earlier video, is one that starts with beryllium and ends with radon, right? Radon, right? So beryllium and then it ends with radon. And remember, groups run from top to bottom. So in this case, this is ambiguous in terms of they're trying to tell you that the numbers here represent groups, right? But they're not telling you that the numbers that represent the groups mean that it runs from top to bottom, which is what it does. Okay, so remember, groups are columns. Columns run from top to bottom. You could think about the Grecian columns that run along the veranda. If you have a veranda with columns that hold up a building. So think about top to bottom, vertical, right? So this is group 2 right here, and if you notice, it goes 1, 2, 3, 4, 5, 6, 7, 8, right up to 18. This is more for college. So what happens in high school is that you study transition metals a little bit, but not so much so that you focus on them like that. So these are omitted for the 3 years that you would be in high school for, until you come out into college and you're like, what's this? Right? So by that time, you'll be able to absorb all the stuff that you need to absorb for college. And this is just your foundation, so that when you get there, you're able to use the knowledge you would have had to apply it to your college years. So again, group 2, this is a circle right here, put my little red arrow, and we're going to investigate the trends in group 2. Alright, so the elements of group 2 in order of first to last are beryllium, magnesium, calcium, strontium, and barium. And that is where we stop, because anything after that is so overly reactive, it just is too much. And here I went and looked up some pictures of how they actually exist, and they look like shiny rocks, which they are. Shiny rocks is what you find in the soil. So like I said, Mendeleev would have discovered some of these elements, and later on other people came on and, you know, proceeded to continue his workings. You know, a lot of times they say great things come in twos, and that is what happens a lot of the time in the science world. Great things come in twos. And at some point in time, you might be having a really good, like, think about this, you might have a really good idea, right? You're in class, and you're like, wow, I have this really good idea. Some ideas come when you're really young. And when you look, like, with the advent of with the internet and social media and stuff, you see somebody else come on, post it up before you, and you used to say, like, damn, I should have done that, you know? So that's what I mean by ideas. Great ideas usually come in twos, right? You're not the only one having the same idea, and it's just a way for the world to keep on going, right? Alright, so we have beryllium that looks like a shiny rock. Magnesium is really shiny, and if you have a really good lab, meaning that you have a lab stocked with resources, you'll be able to see magnesium. You could actually touch magnesium, you could touch it, you could play with it and everything. And if you ever light magnesium on fire, you would see it glow. It's beautiful. I wish I had some now that I could use, but it would be a hazard in my home, in my room. So let's just keep away from that. One day you'll be able to see the video. I think I have one out there floating, but that will take some time for me to find or locate. I've been doing this for years before YouTube. So Alright, and calcium, you can find calcium. Calcium is present in a lot of rocks, just like how beryllium and magnesium is. Calcium is present in limestone. If you've ever been to Barbados, you would notice that the land is very flat because Barbados was basically a coral reef, right? You wouldn't see any mountains there. And the ground is white, it's like just white and pretty. And that whiteness is due to the calcium deposits inside of it. It's made up of limestone. And so if you look at pictures of bones, or if you've ever held a bone, you realize that this white chalky like bone. Calcium is present in bones, present in milk. And we're going to come up to that right now. So the uses of group 2 elements. Magnesium is used in fireworks or to build airplane body pads. And that's because magnesium ignites really brightly. It's bright. Oh, I don't even know how to explain it. It's just bright. So if you want to see this, you could actually, don't even wait on me. Use your fingers. Go and look up on YouTube the burning of magnesium or the oxidation of magnesium or something like that, and you're bound to see a video where somebody's just having fun and they're like, because it's pretty. So that's why magnesium is used for fireworks, because of its prettiness. Strontium is also used for fireworks as well, and it can be found in toothpaste. Magnesium, use it to build airplane body pads, and the reason why they use it for incorporating it into the body parts of airplanes is because magnesium is very light. It's very light. It can float on water, right? That metal is light, and that's what you really want up in the air. You know, you want light material that the wind could really build up under and keep up there. That's a whole other story, right? You try to hear me say the whole other story, but you want enough wind to be able to fill up the capacity under the plane to keep it afloat, right? You want its upthrust force to be much greater than its weight. So calcium is present in milk, cheese, bones, etc. It's very important for your bones, especially when you lack calcium. You end up with some brittle bones. If you hear about astronauts, and you know, gravity is very essential in your growth. That is why we exist on Earth, because gravity keeps our bones strong. Astronauts who live in space for more than 5 years, or they keep going, they end up suffering from something called brittle bones. And let's just break it down really simply. Brittle bones, because there's no gravity in space. And so the bones basically forget that they need to be strong, because there's no gravity pulling on them to tell them, hey, you need to be strong to support your little human person that's outside of you. And so the bones now, they get spoiled to having zero gravity, and they basically become weak, you know? It's like when you stop studying, and it's time to have a test, or even, let's take it out to the studying arena. Let's say you learned to ride a bike when you were really small, and you were riding bikes from the age of 5 to around 12. That happened to me, and that could happen to a lot of people. And so you stopped riding bikes around 12 because your life changed and you had a lot of upstats and changes in your life and whatnot. It's not really like you hated riding the bike, you just had to move and stuff like that. Just something happened, your life changed. And then you come back around the age of 21 and you're like, I want a bike and whatever. The first time you get on the bike, you could still ride it, but you're not riding it as strongly as you would have been if you had continued riding throughout your entire lifespan. You're going to be wobbly, you're going to be wondering, why are you so wobbly, whatever. You'll be lacking confidence. So that's pretty much what happens to your bones. Your bones forget about gravity, and they start to get lazy and stuff, and they just decide, hey, I like this zero gravity thing. And so astronauts suffer from something called brittle bones. And then, yeah, basically they go through life with brittle bones. So strontium is also used in fireworks and can be found in toothpaste, like what I said. And barium is used in medical procedures. they usually, when you're taking x-rays, they give you like barium sulfate, a little salt with barium, and you swallow it so that they could see it traveling through your organs in x-rays. Yeah. Well, you could look it up, but I know you have to swallow something, a barium salt, so that your organs can be seen. Because in x-rays, your organs are not really seen, it's just the bones. So they need that iron, that metal, to see your internal organs. Okay, so the physical properties of group 2 metals. Remember, physical properties mean what you look at and what you can see with your bare eyes, right? So with me, you could see that I have big eyes, and I have a dark rim around my lips, and I have a chubby nose, and you could see things, and I like wearing buns or my hair up and stuff like that. Those are things you see, right? So that is what we chemists term as physical properties, things you see. And so the physical properties of these group 2 metals are that they are found in minerals in the earth, meaning, in the soil. And so they are so reactive that they cannot exist by themselves. They are often combined with other elements such as oxygen, which is a major one, chlorine, or phosphorus, right? So that's what I mean by they can't exist by themselves. You wouldn't hear, oh, calcium itself was found in the earth today. No. It's usually calcium oxide, calcium sulfate, some type of calcium, something. It's like a salt, or oxide, or chloride, something. It's always combined with something because it's so reactive, right? It's like people who have a really fun personality. You don't ever see them just existing by themselves or being indoors. Maybe very few, can't talk for all of them, but the majority of really, really, really hype and outgoing people, they always have a lot of attachments. Like a lot of people like to be around them and stuff like that. So you could say that group 2 elements are hype because they're really reactive. So group 2's metals get more reactive going down the group, and this is because of the more you go down, the more electrons you will find in them. And so you will find that the lower down you go, you're going to start to experience a lot of electron repulsion. You remember that in the last video? So because of this electron repulsion and the lacking of nuclear charge to attract the valence electrons, what happens is that these electrons are like, I don't want to stay here, I'd rather go away, and stuff like that. So for instance, let's talk about the first one. Let's go back to up here. Beryllium. Beryllium has an atomic number of 4. So that means it has, in its neutral state, it has 4 electrons. So that's the beryllium. And so we have our nucleus here, because I need to save space. And remember, if beryllium has 4 electrons, the first energy level could hold 2 electrons. And 2 from 4, see 4 electrons, minus 2, leave back 2. And remember, the second shell could hold 8, so therefore there is space for these 2. And so 12 and 6 o'clock position. Okay? 12 and 6 o'clock position. You need to have the electrons as far apart as possible in your little schematic. And now let's look at magnesium. Magnesium has 12 electrons. So we have here the nucleus. First energy level holds 2. So 12 minus 2 electrons, we'll leave back with 10 electrons. So the next energy level holds 8. So minus 8 here. And left back with 2 electrons. So you see, it's the radii is getting wider and wider. And so now we're going to move on to calcium. Now that's the one where we stop at. We always stop at calcium because remember I told you it gets a little complicated after that. And doesn't, nobody goes any further than calcium at high school level, so why bother yourself, okay? So, calcium has 40 electrons. So we start with 20. 40 is calcium's mass, sorry. So we have 20 electrons, and we start off with the nucleus right here, and the first energy level holds 2. So we're minus 2 electrons, and we're left back with 18. So the next energy level holds 8. Why I didn't do 12 and thing position like that going around, because I know 8. So all of them will be filled. So we minus 8 here, and we leave back with we're left with 10. And then we go again. Here. Remember, in the third energy level, what happened? We have 8. We go with 8 first. And so, since 8 is less than 10, we could fill it up. So, minus 8 electrons right here, and we're left back with 2. So, you realize the atomic radii, I can't say it more than enough, gets larger and larger as you go down. And if you look at it, you realize there's a trend. In group 2, the outermost electron, if you look at it, let's just start with this. Beryllium. Beryllium is in period 2. It has 2 rings. So because it has 2 rings, it's in period 2. And like I said, every time you move into a next period, the electrons have moved into another energy level. So here you realize this has 3 rings. So therefore, magnesium is in period 3, right? So this is period 3. So you realize now that as you go down the group, the periods change. And this one is in period 1, 2, 3, 4, period 4. But what stays the same? The count of the valence electrons in the outermost shell. They all have different outermost shells because the outermost shell for this one is period 2, energy level 2, and the energy level 3 for magnesium, and energy level 4 for calcium. But in that valence electrons, in that valence shell, which is the outermost shell, it has the same amount of electrons each time. 2. Now imagine now that the atomic radii has increased. In here you have something called a nuclear charge, which is due to the presence of protons, a positive charge. And this positive charge gets weaker as you go away, right? It's like, let me see how I could say it. Let's see how I could say it. I don't know how I could describe this one. But as the electrons move further away from the nucleus, the pull of the nuclear charge gets weaker. So therefore, the lower down you go, the wider the atomic radii, and the more likely these electrons want to leave, right? So they become less needy on the nuclear charge, or they just want to leave. And the leaving is due to the fact that they want to achieve a perfect octet. In this case, the perfect octet here will be 8. An octet means 8. This one will be 8 on the inside. It wants to achieve that perfect. It wants to achieve something that resembles some sort of stability. And these are not stable out here, okay? Because this shell can hold a maximum of 8. It only has 2. This shell can hold a maximum of 8 and 10. It only has 2, right? So this one, yes, it can hold 8, and I said that it wants to achieve a perfect octet, but this shell in here is special. The first energy level only requires a maximum of 2 electrons. So yes, beryllium will be happy to lose these 2, but not as happy as this one, because the nuclear charge here is so much less, because these electrons are so much farther away from the nucleus than these electrons. I hope that helped, because sometimes they ask questions and you become baffled, and you don't understand why. So it's always, the more reactive you are in group 2 is based on electron repulsion, because you have all these electrons up in here. And the nuclear charge is not that great, but we don't deal with nuclear charge when we're dealing with group work going down. You deal with nuclear charge going across the period. Whenever you deal with going down the group, you deal with more so electron repulsion. If you look in here, there are a lot of electrons. It's like, get away. I don't want to be next to you. In here has 2, in here has 10, in here has 18. And this is combating 18 electrons. So, well, 9. Let's share it between the two. 9, 5 each, 1. Okay? So I hope this helps. So it's electron repulsion. That's why it's so reactive. Okay. Alright, so some reactions of group 2 elements. They react with oxygen to produce oxides of themselves. Example, magnesium oxide produces magnesium and oxygen. And here is an example of a chemical reaction. Okay, so I have it written up. And you're going to learn about this later on. It's coming. So I'm not going to go too deep into it. Just look at it. Just get your eyes accustomed to it. And by the time we get to it now, you'll be like, I remember that. I remember seeing that. Right? So magnesium plus oxygen will give you magnesium oxide. And you would have been hearing me talking about oxides. That's what it means. A metal reacting with oxygen to give a metal oxide. So it's magnesium oxide. And we have calcium reacting with oxygen to give calcium oxide. And then we have here metals reacting with water to produce hydroxides of themselves and hydrogen gas. And we also see it with calcium. Okay? They react, so these are known as the chemical properties. Whereas before we were dealing with the physical properties. Physical properties, again, is things that you see like this. This is how they look. And now we're dealing with the chemical properties, what they do. This is chemical properties. So here we have they react with the hydrochloric acid to form chlorides of themselves and give off hydrogen gas. Example, magnesium chloride produces some hydrogen chloride. So we have magnesium, hydrogen chloride to give magnesium chloride and hydrogen gas. And you're going to learn all of this coming up. So brace yourself. Brace yourself. This is just for you to look at and say, wow. But by the time you get here, you'll be so seasoned. You'll be like seasoned chicken. Oh my God. Oh, I didn't expect myself to laugh after that. That was really corny. Life of a chemist. I guess I'm seasoned chicken. Oh my God. Anyway. So chlorides are often referred to as salts. So the reactivity and ease of ionization. The reactions of group 2's metals are based on losing their valence electrons to form ionic bonds. And you see these words that I have highlighted in color? Get used to them because we're going to be coming up with this just now. Okay, ionic bonds, that's a type of bond where it only occurs between a metal and a non-metal. So ionic bonds occur between a metal and a non-metal. Okay, and remember you find the metals in group 1 and 2 and 3 except for boron, and then you have the non-metals. Okay, so the energy needed to remove an electron from an atom or ion is called its ionization energy. So anything found in group 2 would have 2 ionization energy because, well, it could have more, but you more hear them talking about 2 because you need to remove the valence electrons. Anything after that is going to be a little harder to remove because the nuclear charge is going to be greater on these on the inside. So once these electrons go, they're removed from the atom itself, you have ionization energy. So the first one is called the first ionization energy. The removal of the first electron is called the first ionization energy, and the removal of the second electron, second ionization energy. So when group 2 metals lose their valence electrons, they become ions and carry a charge of 2+. since they lost 2 electrons. Example, Mg2 plus or Ca2 plus. Factors that affect ionization: the size of the atom, the nuclear charge, and its electron-electron shielding. Right? So obviously this will ionize much quicker than this one. So calcium will ionize much quicker than beryllium because of electron-electron repulsion. The ionization meaning loss of valence electrons. Size of the atom is nice and fat, good, yeah. And so you lose the electrons really quickly. Alright guys, this was fun. This brought me back to my days in college because I didn't learn shit in high school. This is my advice to you. Pick something you love and try to use it for your benefit.